Okay, ladies and gentlemen, and as you know, this is basically going to wind up being our last full week of notes and stuff and work. We do go all 5 days this week, so I'll have stuff for you guys to do. As of right now, I'm looking at doing what are called arithmetic sequences today. Tomorrow we'll talk about arithmetic series. On Wednesday we'll talk about geometric sequences. On Thursday we'll talk about geometric series, and then Friday we'll probably talk about the infinite series and go from there. Again, these are going to be stuff that you'll have some formulas to work with. As we go along, I believe there's only going to be a total of 5 different formulas. Just keep tabs on them. This is going to be the first one that you see right here, and we'll go through what all of this stuff means as we come along and we go through it. So, without any further ado, I hope everybody's doing well. I hope you guys all had a wonderful Mother's Day with your families and stuff, and I hope everybody's feeling healthy. And I really miss seeing you guys and having some fun in the classroom. So hopefully we'll have a little meet this week, and we'll say hi and go from there. So here we go. Arithmetic sequences. Arithmetic sequences, are a sequence of numbers that all have a common difference between them. If you look at the one that I put here for a quick example, I start at -3, 1, 5, 9, and 13. You'll notice that between each one of these things, it goes up by 4. So the commonality between each one of these is a +4. So you would be able to figure out what the next term in the sequence is. Well, I would just add 4 to 13, I would get 17. Add 4 to that, I'd get 21, 25, and so on and so on and so on. So what we wind up doing here is that you can use this formula here to figure out what the general rule is for what's called arithmetic sequences. Now, there's a couple things that we have to define here. In this formula, we have what's called the a sub n. This subscript means it's the nth term in the sequence. A sub 1 means it's the first term in the sequence. So, for example, -3 here is your a sub 1. 1 is a sub 2. 5 is a sub 3, and so on and so on and so on. This means it's the first term, second term, third term, and so on and so on. This value of n, again, stands for the nth term, and this value d stands for the common difference. In this case here, our common difference is 4. So what we want to do, if I want to write out what's called the rule for the nth term, this is the rule for the nth term. We start with the first term. In this case here, our first term was -3. We don't know what n is because we're using that as a, what do you call it, our nth value. And then our d value is 4. So our nth rule would be first term, -3, plus n minus 1 times 4. So what we do here is we want to write this into slope-intercept form because basically arithmetic sequences are nothing more than slope-intercept. So I have to distribute the 4 to both terms here. We have 4n minus 4. Combining your like terms here, and your rule for the nth term would be 4n minus 7. Now what's nice about these things, since you guys have your graphing calculators still, if you want to make sure that you did this correctly, if you go into your y equals, oops, sorry about the glare. If I go into my y equals and I type in what I'm thinking is my rule for my nth term, I put in 4x minus 7, and I hit table. If I'm looking into my table here, I want to make sure this sequence shows up. Obviously, we're not looking at these are our nth terms we're looking here, but you'll see I have -3, 1, 5, 9, 13, and so on. That tells me that I did this part here correct. Okay? Let's take a look at another example. Here we have another set of an arithmetic sequence. And now in this case, I want to figure out what is the 20th term in the sequence. Well, in order to do that, first thing we have to do is write out the rule. So our rule for the arithmetic sequence, their nth term, excuse me, is your first term plus n minus 1 times the common difference. Well, we know our first term is 50. Our common difference is, well, notice that it goes down by 6, down by 6, down by 6. So our common difference here is -6. So we write out the rule. Our nth term is going to be 50 plus the quantity n minus 1 times -6. Distribute back, so we have -6 plus 6, oops, forgot my n. Combine my like terms, and I get -6n plus 56 is our nth term. And if I want to figure out what the 20th term is, This is the n value that gets thrown into here. So this becomes the 20th term will be negative 6 times 20 plus 56. Again, what's really nice about the graphing calculator is that if we put in our equation that we first come up with here, negative 6x plus 56, and I go again to my table, I should see my sequence of numbers in here somewhere. See how I have 50, 44, 38, 32, and so on and so on. So I know that it's going to have to work. Now, if I want to know what the 20th term is, notice all I'm doing is substituting in 20 into my table. I can either scroll and look for 20, and I get negative 64, or if I did it the other way, negative 6 times 20 plus 56, and I still get negative 64. Okay. Nice to go back to some really basic slope intercept and, ooh, I need to sand this table down. It's very old. All right. Okay. Let's try another form of this. Again, we're working with an arithmetic sequence. We know it's going to be, our rule is our first term plus n minus 1 times our common difference. And now in this case, I'm given the 13th term, but I need to figure out what the first term is. So we have to do a little bit of legwork. If you think about it, though, you have 1, 2, 3, 4 variables. And we can kind of move things around here and there to figure out and solve for one of them if we need to. We know that the 13th term is 30, which means the n value is 13. So I know that this has to equal first term times 13 minus 1 times my common difference of 3 halves. Let's grab with a plus sign here. Okay. Now, we know 13 minus 1 is 12. If I multiply that by 3 halves, I'd get 18. So first term plus 18. If you forgot how to do that, you can do 12 times 1.5. That's what 3 halves is. It's really fast. And then this has to equal 30. Well, now it's very simple to figure out what your first term is. Your first term has to equal, well, subtract this over, and you wind up with 12. So we know our first term, we know our common difference, and we go back to rewrite it. With sequences in series, there's just a lot of rewriting of the generic forms of the equations to go back and forth to get into the slope-intercept form of the problem. So we have 12 plus n minus 1 times the 3 halves. Distribute in, we get 3 halves n minus 3 halves, and then we have a 12 over here. Now, when I'm looking at the 12 and I have to subtract 3 halves, I want to keep it in terms of the fraction. So I know that 12 is the same thing as 24 over 2, so I'm just going to do this real fast. So 24 subtract 3 gives me 21. So my final answer, my nth term, is going to be 3 halves n plus 21 over 2. Okay. And the very, very last example is if you're given 2 terms within the sequence. So first thing we do, we're going to figure out, you know what, we're not going to do this. All right, check out for formative, and we'll see you guys later. Have a great day, and if you have any questions, let me know.